Okay, so we've downloaded the file called Portfolio Optimizer from Learning Suite. Should have one sheet on it with some ticker symbols here and a couple of buttons. This actually used to be the kind of the running case that I would use for teaching this class. And so we'd say add tickers, and it would bring up a user form. This was a user form we used to build in class. The idea is you've got a list of tickers, specify some start and end date, choose what source you want to bring the data from, and then that would just bring that information right here onto this page. So here's the idea. Here's what we're trying to do with this example. The idea is we've got a given set of stocks, and we have a threshold for how much risk we are willing to accept in this portfolio. The question is, how can we allocate the money that we're spending to these stocks so that we get the... What are we trying to do? Oh, no. It's not that we have a risk we're trying to take. It's that we have a required return. There's some expected return that we want to get from this. What we want to do is figure out how do we allocate our portfolio across these stocks so that we will minimize the risk and yet be able to achieve that expected return. So this is a problem that is, there's no analytic solution to this problem. This is a problem that we have to use with optimization. And so I'm going to go ahead and kind of get started with this. I'll just work with you the 10 tickers that we have here. I'll say process model. And what will happen is it'll take these tickers, it will go out to finance.yahoo.com, bring in historical monthly data for these stocks, and then build a model up to the point where we're ready to optimize. So all this data, it actually just brought in dynamically from finance.yahoo.com. One vector of information for each ticker that we have here. So here's American Express and Apple, American Express and Apple. What these are is these are the month-over-month changes. And so from the prior month here, this was a 1% increase. Then the next month was a 4% increase. Then a 1% increase. Oh, what time is this? Oh, it's the late 90s. Don't base your portfolio optimization on this data because the late 90s is a crazy time in the market. We're getting 4% month-over-month in growth. This is crazy. And analysts were looking at this time going, maybe this is the new normal. It wasn't. Okay. So then we have a summary of these vectors of numbers. So the average monthly increase for American Express was 3%. The average monthly increase for Apple during this time was 2%. By the way, it was a good time to buy Apple. Apple isn't trading very high in the late 90s. And so then we have a standard deviation. The standard deviation tells us, kind of as we go from month to month, we've got all these average monthly these monthly changes. The standard deviation tells us how far does this thing swing. So how much volatility is there in that particular stock? So a higher standard deviation would mean there's more deviation around the average that we're seeing for that. Then here we have a correlation matrix. Correlation matrix just says, when we've got two tickers, a high correlation means when one goes up, the other one tends to go up. When one goes down, the other one tends to go down. So we would expect some things that are like tech stocks to move largely together. What's our highest correlation in here? Anyone see a high correlation? Here's 0.4. That's pretty high. You got a higher one? Microsoft and Dell. So here's Microsoft and Dell. Yeah, 0.54. That's really pretty highly correlated. That means when Microsoft has a good month, Dell tends to have a good month too. When Microsoft tends to have a bad month, Dell tends to have a bad month. Larger. And so that's how these are correlated. Questions here? So this is all just kind of background numbers that Excel is calculating for us so that we'll have what we need to do the optimization. And that's then that we see on the model sheet. And again, all these sheets are generated dynamically through code. We can go look at the code and there's nothing magical about this code that you wouldn't understand. A little help, looking at it, you might spend some time thinking about it, but nothing beyond what we've covered in class. So the model sheet says, okay, here is the portfolio that we're going to actually build. It's got each of the stock tickers. Right now it's allocated them evenly, so each one has 10%. We're saying allocate 10% of our funds to American Express, 10% to Apple, and so forth. This is the mean return over that period for each one of these tickers. And so this is just maximum return and minimum return. What does this mean? Maximum and minimum return, what does that mean? It's just the maximum and minimum from this set. The highest performing stock during this time had an 8%, 8.7% increase. Who is that?
Dell.
So that's Dell. You'd have a hard time doing this with Dell today. Why? Yeah, they're no longer publicly traded. So if you want to use current data, you probably should get Dell out of the mix. And then the lowest performing stock was practically Apple. That's kind of amazing.
Airlines.
Southwest Airlines is the lowest performing stock. So what that means is this is the range in terms of. So what we're doing here is we're looking in the past and we're saying our best guess about what the future is going to be is the recent past, or in this case the late 90s. We probably should update those dates to more recent times, but we're saying that's our best guess. And so if we think the future is going to be something like the past, then we shouldn't expect to get anything more. No matter how we allocate this, we shouldn't expect to get more than 8.7% return. No matter how we allocate this, we shouldn't expect to get less than a 2.1% return. So that's what those numbers are. However we allocate this, these weights are going to need to sum to 1. We have to allocate our full portfolio. And so then what we have here is a constraint that we're going to use for the solver. We're saying that this is the return that we're expecting. This is our expected return from the way that we have this portfolio done. It needs to be greater than some required return. So we're putting in, here's where we say, I need to have some required return. I'm going to simplify this by just putting 0.05. So this is the part that I'm going to ask Solver then to work on. I am trying to figure out how to allocate these or change these weights in such a way that I get at least a 5% return. Now, the portfolio variance is going to be my measure of my risk. So I would like the variance to be as low as possible. And so that's what we're going to tell it to do. So folks, here's the question. Could you change some numbers up here to where we still are getting at least 0.05? Right now we're getting 0.03, so we're not even getting the 0.05. And we're able to reduce the variance. All we're allowed to change is how are we allocating this. So let's think about this. If I need to get at least 0.05. So if someone give me a change that I can make up here in my weights, that would increase my expected return.
All of them 0 except for 100% Dell.
Okay, so what you're saying is that if we said dump everything into Dell, everything else 0 and 100% in Dell, then this is exactly what we would get. So by trading off something that has a low expected return for a higher expected return, specifically something lower than 0.5 for something above 0.5, is Dell the only one above 0.5? Yeah, we got to get some more Dell in this. So I'll change this to say 0.2. Where are we right now? We're at 0.036. So I'll change that to 0.2, and I'll change Southwest to 0.05, and I will change Apple to 0.05. And that should give us, yeah, so that's giving us a higher amount. We're not quite there yet. So here we are looking at 0.04 from 0.03, so that's good. What I didn't notice, what happened to our variance? Did we get more risk by doing that? I just don't remember. Ultimately, folks, this is exactly what Solver is going to do. We're going to give Solver some constraints. It is going to say, I'm allowed to play over here with these numbers, and I'm going to plug in numbers, watch how this set of formulas responds, and as I make a change here, if it takes me further away from my goal, I won't make that change again. If I make a change here and it takes me closer to my goal, I'll make another change similar to that one. And that's what an optimization analysis does. So let's just go ahead and run this once by hand, and then we'll take a look at what it takes to automate the process. So first of all, let's make sure you have the solver because it's not necessarily installed by default. If you come to your Data tab, if you've got it, you should have solver marked right over here. All the way at the right, in an analysis group, there should be solver. Is there anyone who doesn't have solver showing? Everyone's got solver? Good. We'll choose solver, and now we'll configure the solver. So the solver has one objective. It has one thing that it is trying to do, subject to some constraints. In this case, what we're trying to do is we are trying to minimize the portfolio variance. We want to reduce the risk subject to a required return. And so this is going to be, I'm going to select this cell right here for portfolio variance. I don't want to maximize it. I want to minimize it. So overall, that's the objective. Solver is going to try to make that cell, D12, as low as it possibly can. Now, if I just set it to go now, what would it do? Yeah, it would get rid of all of these. You want that number to be low? Don't buy anything. That's really low risk. You're not exposed to the market at all. Actually, it might even go put a bunch of negative numbers in there because that would even make it. Actually, the variance would then go up. Yeah, so it would zero those out. So we have one constraint, and one constraint is you've got to allocate everything. You've got to have 100% allocation. Well, that's the very purpose of this cell right here. This is just the sum of all these weights. And so one of our constraints is going to be whatever you change. Oh, first let's tell it what it's allowed to change. So there's our objective. What are we allowed to change? We're allowed to change this set of weights right here. Solver is allowed. That's solver's playground. Change the numbers in here. Now the first constraint is, however you change that, those numbers need to sum to 1. And so that's going to be a constraint right here. So I'll come to my constraints. I will say add. And my first constraint is going to be sum of weights needs to be equal to 1. I'll add that constraint. I could say OK and then add another one. Or if I just say add, that one's now been added and I can make another one. The next one is that my expected return right here needs to be greater than or equal to my required return needs to be greater than or equal to my I heard some mumbling. So this is my required return. This is my expected return. The expected return needs to be greater than or equal to the required return. And so that constraint here will be whatever value we have right there. I'll say OK, and I should see those two constraints plugged in here. Make unconstrained variables non-negative. I think at this point, I'm just going to accept the rest of the defaults. Let's hit solve and see what it does. Hopefully, it'll tell us that it found a solution. Solver found a solution. All constraints and conditions are satisfied. And as we see here, yeah, we got a lot of Dell. We also got a lot of GE, some Microsoft, some IBM, American Express. What they're saying is, look, don't buy any Oracle or Southwest Airlines or Apple at this point. And so that's how it is optimized that. Let's take a look. So I'll say OK. It's kept the changes that we made here. And yeah, it's giving me that 5%. And it's run this portfolio variance down as low as it could. Hey, before we were at like something like 0.04 was our variance, right? It's reduced this by an order of magnitude. We're now down 0.004. So that's really pretty good. And we got all the way up here to 0.5. So we didn't play with those numbers very long, but Solver was able to do it in a much more sophisticated way and give us just the way that we should distribute this. Okay, so any questions on just kind of the idea of Solver? Yeah?
What did you select again when you just opened Solver?
What did I select when I opened Solver? I'm not quite sure you understand the question, but let me open it again and maybe it'll come forward. How did I configure Solver?
Yeah, that's what I was
Yeah, so and we're going to do it again. We're going to do it and record ourselves. So we're going to go through this one. Okay. So now we've got to actually see the code that gets recorded. Now, folks, how many of you have ever looked at something that the macro recorder recorded and said, that really looks like a stupid thing to do. Anyone look at that and go, why did they do it that way? Yeah, look at that, not the same. Why did they do that? Everything we've done so far, the macro recording process was written by Microsoft. And so they're at least consistent. Now, it turns out the solver is actually written by another company. It's an add-in written by a company called Frontline Systems. I don't know how much they get paid by Microsoft to plug this in, but if you are serious about optimization, you might go and get a different plugin that's more capable than the built-in solver. The solver that's built into Excel is really pretty capable, but if you ever go, you know what, I need a better one, Frontline Systems will sell you a better one. You'll pay more for that add-in than you paid for Excel, for sure. But it's a different company. So Frontline is the one that did the recording, does the recording from here, and so it's going to be even weirder than we see. So just kind of get ready for that. Let's go ahead and record. So I'll turn on my macro recorder. Developer tab, record macro. Macro 1's a great name for it. We're going to end up kind of looking at the code, kind of cutting and pasting from it. So I'll call it macro 1. And we'll just go through that same process. So I'm going to come to my data tab, open up, draw data. I'll come to my solver, and I'm going to start by resetting everything here. Reset all. Let me just click on reset all. Reset all things, yes. Reset it. This is important because what happens is that the solver model kind of gets built into this worksheet. I mean, it's recorded in this worksheet. And so if I just set up the solver and then said my code is just going to run the solver, that's not going to be very good because the user might come in here, make a change to the way that the solver is configured, and I want to make sure that it's configured the way I'm telling it to configure it. So I always want to start out my solver configuration by saying, I don't know what's in the solver right now. The user could have put something crazy. Reset everything, and then go through the process to add those again. So we'll go through that same thing. Our objective cell is going to be the variance. We're going to minimize it. Tell it what cells it's allowed to change. Subject to 2 constraints. First constraint is G6 has to equal 1. And my expected return is greater than or equal to my required return. I will go ahead and say solve. I did that pretty quickly. And I'll say OK. But those are your constraints. This is your range you're allowed to change. And then these are the areas that you're interested in. 2 constraints are here. Your objective cell is here. And then these are the cells you're allowed to change. Questions? All right. Did I stop recording yet? Stop recording. Let's go take a look at that code. Should be in a new module. So here's module 2. And here's macro 1. So, first one we have here, solver reset, that looks okay. Oh, you know what, we better check one thing. Before we go too much further, let's choose Tools, References, and make sure that you have the reference to solver. So you want to make sure that you have solver here and that's checked. Is there anyone that's looking at this and going, I don't have solver checked yet? Hopefully it's going to check automatically, but in the past we've seen where it didn't. Yours is checked okay? How many of you have actually verified, yeah, it's checked for me? Okay, looks like we're in good shape. It seems like kind of a weird thing, but in some cases it'll record the code okay, but then you go to run it, it doesn't have the reference to the solver, and so it doesn't have any idea what it's talking about, even though it just recorded it. So that's one thing, you've got to make sure the solver is checked in the references. Okay, so here's the first one. This actually is pretty nice. Any idea what this statement does? Resets the solver. Great. Now we have this next one. It seems like a really weird name, solver OK. We've got a procedure called solver OK. All right? It's got some parameters here. We're going to set this set cell, it's a parameter called set cell, and then D12. So what do you suppose this is doing? What is this? Yeah, this is the goal. This is the target cell. Now, min-max value gets a value of 2. What do you think 2 means? Yeah, minimize. One of the things we can set it to is we can either set it to maximize, minimize, or try to get to a particular value. We don't care what a particular value is, but it's still recorded here because we're minimizing, so this is irrelevant, but it's still here. By change, then, gives us the parameters that we're allowed to change. Now, this is line continued. I'm going to bring this up because I think this will all fit on my screen here. So by changing this value. So here's one of the things, is that solver is configured to do a particular range. And so if I change the number of tickers that I have in my basket, is that a problem? Yeah, because it's hard-coded, that particular one. So we have a couple of options here. One is, instead of just accepting this as this hard-coded string, we could go, it's going to start in B4, we could calculate where it ends. Do you think you could figure out the column number this ends on? Yeah, you could figure that out. And then you could just adjust this so that it brings in the right value. But here's what you're going to notice, is that in the code that built this, as part of the process of building this, it builds that range out and then it names it. You see it? It's a named range. And so even easier than that, we can just come in here and say weights inside the quotes. And so we don't, because the code already says, gives that range a name, we can just rely on that.
If you were to do that manually, could you just write weights into solver and then it would do the same thing?
Oh, could we have just written weights when we were doing could we typed in weights for the by change? Yes, absolutely.
Yeah.
Yeah, that would have worked. And it still would have put in the range that was here. It wouldn't have brought in weights.
Yeah.
Kind of a weird thing. It'd be nice if it would, but it didn't. And in fact, even some of these, I think it actually showed the names there, but then it actually recorded the hard-coded references. Okay, then which engine we're going to use? It's the nonlinear engine. I don't know enough about the different engines to know which one's better to use. I believe in accepting the defaults here. So someone who's like a global supply chain wizard would probably be able to give us some good information about what the different, why you would choose one engine over the other.
So GRG nonlinear just means that basically there could be more than one peak. So it starts it by a bunch of different points and then goes up to find what actually is the best value.
Oh, really? Yeah. So that sounds like a pretty good one to do. Linear would mean, if it's linear, you're going to have one maximum or one minimum.
The other one that you normally use might be like simplex, which starts in a lot less points, just 2 usually. So if they're like one that randomly has like 4 peaks, then you might miss one.
Very good. So this sounds like a pretty good one to use. Okay, so there's kind of setting up the basic solver. Now, solver add. We're adding a constraint. Cell reference is G7. The relation is 2. What does 2 mean in this case? Equals. Now here's a problem. Formula text. We're gonna see the problem and then we'll fix it. So rather than having to fix the problem so it's not a problem, we'll see the problem happen and we fix it. So mental note, there'll be a problem here. Okay, that's not too bad. Solver add. Now we have another solver OK. Wait a minute. What's different about this solver OK than the last one? What do you see? Well, I changed weights, but that line is exactly the same. Why did it record it again? I have no good reason for that. Does this line need to be there? No, it doesn't. Once is enough, so we'll delete that. Would it hurt to leave it there? No, to leave it there would be just fine. Except that we'd have to change them all to say weights. So here's the next one, another solver add. This one looks pretty good as well. So we've got D10. The relation is 3. What does 3 mean? Greater than or equal to the required return. And another solver OK. Do we need it? Nope. And another solver OK. Nope. Now we have solver solve. This is the one that actually tells it, go ahead and solve it. And then it looks like I recorded myself selecting a range. I don't need that. Okay, so the code that we end up actually needing from what got recorded is quite a bit simpler. And so at this point, we should be able to run this and see what happens. I'm expecting an error. We'll see. No error, but it did this. It came up here, and it solved me to this point and says, do you want to... You know when you get an error? Try to fix the problem. That would be neat. So here we've got to say, okay, now, we don't really want the user to have to do this, because part of what we might want to do is we might want to optimize something, change parameters, optimize again. We might want to optimize 1,000 things. That's the whole reason that we want to write code, is let this go over and over again. Change the way it's done, optimize. Change something, optimize. Change something, optimize. We don't want the user to have to click OK every time. Their pinky is going to get tired, or their fingers are going to get tired. Here's good news. Solver OK, so solver solve. If I hit a space there, it says, hey, there's a parameter. User finish. This is a Boolean parameter. Tell me what you think. Got to be true or false?
False.
User finish false. Let's put false in there and see what happens. Can't remember. Nope, does the same thing. Well, let's put user finish true. That's better. Solves it with that. So user finish almost sounds like you're saying, should the user finish this? You want to say false. No, don't let the user finish this. But it's exactly backwards from that. So by putting solver solve true, that says just solve it, accept the results, and we're ready to move on. Now here's what I want to do. I want to make sure that it actually solves. So I'm going to put this back to, I'm just going to zero these out. And let's solve it again. And it looks like, yeah, we still did. So I think we're okay. So the error that I was getting you ready for looks like it's been fixed. Yep.
I don't know if this is related to the error you thought you might be getting, but the sum of the weights is no longer 1.
Oh, yeah, that's the error. Thank you. Thank you for noticing that. So that's the problem. Yeah, this thing has to sum to 1. We've got a constraint here. So yeah, the problem is still here. And here's kind of the only hint on this. Here it says, what's the formula text? Is this a formula? Formula 1. That's like a race car, isn't it? Yeah, so what we need to do is we need to make this into a formula. If I was making a formula in Excel that just equals 1, what would it look like? Equals 1. And as soon as I put an equals 1 there, I think that's going to do the trick. Yeah, so now our weights are now back to summing up to 1. So that's a weird little thing.
Why do you have to do that? You know?
I have no idea why you have to do that. Especially since we don't have to put equals required return down here in this formula text either. It could be that because this is a named range, it already figures out it's got to figure something else out. But this has to be, we got to put that equal sign.
So does that mean if the parameter happened to be greater than or less than or something like that, we have to put greater than 1 or less than 1?
Oh, no, I don't think so, because so the question is, what if it was greater than 1? We put greater than 1 here? And the answer is no, because that's held right here in this relation. So it's looking at this particular cell. It knows the relation it's looking for, greater than, equal to, less than, equal to, whatever. But then what it's comparing it to, it needs to be a formula. And again, there's no good reason for that. In fact, when they wrote the macro recorder, they were thinking that just whatever's there will be fine. But it needs to be set up as a formula. Okay. Questions? All right, let's go take a look at the code that generates so far what we've done, and then we'll integrate our recorded code into the code we started with in this example. So back to Module 1. So there are a few sub-procedures here. So this one should look pretty familiar to you. All this does is it shows a form. So there's a form called ticker form. Tickerform.show just shows the form. That's pretty straightforward. Build model, then, is the one that gets executed when the user clicks on the button that builds the model. Incidentally, why did I put these buttons on the sheet instead of up in the ribbon? Any idea? Because I wrote this example before there was a ribbon. The example's been around for a while. if I was writing this example again today, I'd probably put these two buttons up in ribbon modification. Okay. Yeah, in fact, when was it? It was probably around 2001 or 2002 that I was doing it, based on the period that we're looking at in the stock. Okay, so here, build model, and we know we haven't really seen this before, but this is a really common approach to designing an application. Is we have some sub-procedure here that really just is like the main control procedure of everything else. It doesn't do, there's no logic in here. All it says is call this sub-procedure, then call this sub-procedure, then call this one, then call this one. So we've taken the whole problem and kind of divided it up into smaller pieces, each one that does something, and then the main procedure just says run all those individual ones in order. It's kind of nice when you're developing this way because you can say, all right, all I need to do is create a sub-procedure that clears all the old sheets. We should be able to find that. Clear old sheets. Clear old sheets, here it is. And what does it do? Turns the alerts off. It's going to get a loop that goes through all of the sheets. And if the sheet we're currently looking at is different than tickers, delete it. So whatever, when you run this, whatever sheets are here, except for the ticker sheet, are just going to get blown away. Well, what if the user's added some new sheet and they've done some calculations on it? What will happen to that sheet? Poof, it'll be gone. Next one then says build new sheets. Build new sheets, what is that? So build new sheets does, kind of, it's a lot of heavy lifting. It creates a sheet after tickers, names it Yahoo. Creates another sheet after tickers, calls it Frontier. It creates all these different sheets. And then it goes and writes some text onto these. It's actually putting all that text onto those sheets. When those sheets came up, they had text on them. This module is just building all that text onto it. So we can delete the sheets and bring it back from scratch. Questions here? Here's get data. Get data just, as you might imagine, gets the data. How are we doing this? Oh, we're probably just using sheets. Oh, it's calling another function called get historical data. It must be defined here somewhere. But it's just pulling the data from finance.yahoo.com. In fact, this one might be interesting because it may take a different approach than we've seen. Yeah. So the object we worked with before when we worked with it with the server was an Internet Explorer object. It's the whole browser. Full capabilities of a browser. It turns out that built into the Windows operating system is a different object called Server XML HTTP. It's an object that's designed to communicate with a web server. It's not nearly as capable as Internet Explorer. It won't be able to remember your session, so if you log in somewhere and whatever, it won't remember that. It doesn't have any visual representation, so there's no browser for you to look at. It's just something you can manipulate through code. But that's the approach that this code takes. It creates that object, and then it uses that object to get information from a URL. And so this URL, in fact, looks like I printed it out. Here's the URL that if you pass that URL to finance.yahoo.com, it will just download a CSV file that has the monthly G equals M, that's monthly, with the date range specified. It gives you historical data. So finance.yahoo.com just has an endpoint that we can access that gets that data, and that's what the get historical data function does.
How does the downloading work? Does it go into your downloads file on your hard drive?
So does it even ever actually download that file? And the answer is no. What this does is it brings that file into a working space inside that object, and then I don't think I'm even saving it out as a file. I'm probably just, I'm just parsing through that file, saying let's look at the first line, split it up based on its commas, and write that data out to the sheet. So even though if I were to hit this thing with a browser, if I was to take one of these URLs and plug it into a browser, that should trigger a file to download. With this other object, it doesn't actually create a file. It brings it into its own working space, and if you wanted to write it out to a file, then you could take that information and write it out to a file. But in this case, we don't ever really need to put it to a file. We've got the data we need there, and then we just read it into Excel. Questions? So that then gets the data. So if we look at the data, that should be the last thing that we have on Yahoo. So this is the actual data that's coming in. The last one we received was Dell. So it has, it opened on September 1st. That was what it opened at. This was the high and low during the day. This is what it closed at, was the volume. And that's the adjusted close. I am actually adding this percentage change in here to be able to calculate what we need to calculate. So this is the raw data that's coming in. I then plop in this formula, and this then is the vector of information that I'm just copying over to my Consolidate tab. And that must be happening in a different procedure. Yeah. So get data, and then there's a summarize procedure. Summarize. It's copying that over, I think. Been some time since I wrote this. But essentially, that's going to get the data from what we brought onto the Yahoo sheet over here onto the Consolidate sheet, probably. Maybe Get Data does that. Maybe Summarize is building this. Building this and then building the model. So let's go through that process to get the data into this format. Okay. From there, then what we're going to see is that the next thing is it's calling a procedure called config solver. Right now, that's grayed out. There's nothing there. So that's what we have to do. So the next step here is to get this thing to configure the solver. So I'm going to uncomment that, and I'm going to find config solver. Here's config solver. There's nothing there. What do you suppose we do to configure the solver? Let's take a look at the code that we wrote. What do we want configure solver to do? Yeah, we're going to want it to reset whatever's there, blow it away. Then let's set the destination, the target cells, set the... See, we don't want to actually solve with it, we want to go ahead and configure. So I'm going to copy that code, and I'll bring it over here into my config solver. So there's solver will now be configured. And then we've got another one here called run solver. And run solver, probably just the one last line, solver solve true. That's pretty simple. So now, we'll leave Find Frontier commented out for right now. So the difference that we've done now is that it should, if we run this thing from scratch, it should go bring in the data, build the optimization model, and or build the worksheet, set up the optimization model, and solve it. Let's just give it a shot and make sure that it does that. We'll come back to tickers, hit process model, blows the sheets away, brings in the data, and then should give me the model. Looks like it didn't do it. Oh no. A couple things I can think of as to what might have gone wrong here. Let's go take a look at the code.
I have a quick question.
Yeah.
Is there a reason why you separated out the run from the solver? Like, why you separated those two?
Yeah, so the question is, hey, what's the big deal here? Because you just run these in sequence anyway. And the answer is, where we're headed with this example is we're going to say, well, let's suppose that I want to see not just one point, but I want to be able to build a graph that says, well, what if I'm willing to, or what if I'm requiring a higher return or a lower return? I want to be able to graph multiple ones. And so configuring the solver is going to be the same, but then all I'm going to do is change what my required return is and then solve it again. So I'll configure it once, and once the solver is configured, I'll change the parameter and then say solve. Change the parameter and say solve. Change the parameter and say solve. Would it have been the end of the world if each time I did that, I blew the solver model away and then reconfigured it? No. It would take, another few milliseconds. Not a big deal. Okay, so here's one thing when we're configuring the solver. We need to make sure when we work with that, when we configure the solver, that solver assumes that the solver model is on the sheet that we are working on. In fact, the sheet that was active when that code ran looks like it was the Consolidate sheet. I wonder if I built a solver model here. Yeah, I think so. I think I built the solver model on this sheet. I come over here and look at solver. I don't think we'll see a solver model. Yeah, this one's not configured. So I actually, because consolidate sheet was the active sheet when I said configure the solver, it built the solver model here. Does that solver mean anything on this page? Absolutely not. So when we're configuring that solver, we darn well better make sure that that sheet, the sheet called model, is the active sheet. So sheets model dot activate. That's going to have to be true when I run the solver as well. So I'm going to put that same thing. Just every time I run the solver, let me make sure that the right sheet is active. I'm going to try that again and see if it solves.
Why didn't it throw an error message if it ran it on the wrong sheet?
Oh, so the question is, why didn't it throw an error? And the answer is, you can see it. It looks like it actually did change some values in here, didn't it?
But like it didn't change the other one back to 1, right? Is that a...
Well, it doesn't change that one. All that one's doing is it's checking to make sure, it's checking to see if that value is equal to 1. That value never equals 1. So probably what you see what would happen is if we just try to solve it right here. This is what happened. Solve. It said, you know what? We can't do this. But because we told it user finish equals true, then it suppresses all communication with the user. And so this just didn't get shown. So it ran that, but didn't show anything to the user. Did just what we told it to do. So there just was really no error.
I'm sorry, I still don't understand why it's throwing an object or an error message when we run it on that worksheet.
Well, it's not really,
Or a message saying, hey, something's wonky here.
what it's saying is that, listen, your objective cell's got to be a formula. The whole idea here is that the objective cell, we're going to change some stuff, and we want to watch how that objective cell changes. That has to be a formula. And so solver is saying, you idiot. There's no solver model here. It doesn't matter what I change here. It's never going to change the target cell because it's not a formula. And so, yeah, it's giving it, I guess this is an error message. It's not configured correct.
And then our OK, or stuff that says click OK, is actually suppressing the message that we just saw.
Yeah, it's not the OK. The one that's suppressing it is this one right here.
Yeah,
Solver solve true. Yeah. So the point is that now it should build the solver model on the right sheet because we're telling it activate that sheet before you reset the solver and configure. I'm going to give that another shot. That looks better. So here we are. Portfolio variance is 0.006.
The weights have negative numbers.
Ah, yeah, so we went negative here. Another constraint that we can add to make sure that it's not negative. Let me just go ahead and see what that one is. Record this again. Then you can just add the code that does that. Make unconstrained variables non-negative. It kind of seems like that should have been there. Unconstrained variables non-negative. Let's try this again. Solve. Might be an option.
So you have to add another constraint and make all of those greater than or equal to 0.
Yeah. Okay, let me add that other constraint in. Add. I think I can do this all at once. This range has to be greater than or equal to 0. That looks better. Interesting that it actually did that the first time by itself. Let's take a look at what that recorded. This should be a pretty simple constraint just to type in. Solver add, here it is. Bring this into where I'm configuring my solver. And this will be our weights ranges again. And I'm going to set that to equal to 0. Greater than or equal to 0, and that's got to be equal to 0. So this is the line that we did not record the first time. Thank you, whoever gave me the tip on that. So now, we run this again. I know you probably haven't had time to copy that all in. Let me run it and make sure it works. And then we'll go back and take a look at it. Well, looks like it didn't. Let's look at the solver. Weights greater than or equal to 0.
You do have to make each cell.
Because that's referring to the range, right? Weights is in the entire range.
Yeah, no, I don't. I'm certain that I don't have to put those in individually. Let me solve here. When I solve it by, I configured it but didn't solve it. You just run the whole thing again. Okay, it looks like I need to do a little bit of work here to figure out what I'm missing on getting this constraint to work. Presumably, if I went in and put every single one needs to be greater than or equal to 0, I'm certain I don't have to do that in the solver. Go ahead.
So I think in solver there's a constraint position. So like you can add, I don't know how many decimals. So like if you go to solver and options.
Solver options.
There's like constraint position. So like because right now you're getting like a number that's almost 0.
Oh, you're saying it's really, really close.
Yeah.
It's automatic. Oh, it's right here.
But the thing is like that -1 divided by 10 to the 10th power is like 0. So
Oh, yeah, very good. You're saying that's essentially 0. It's just a precision problem.
Yeah.
If you press optimize on it, it actually zeroes it out. Like,
If I run this again.
no, this button on the sheet.
Oh, this one?
Click that.
So yeah, that's all that's doing is it's calling run the solver. And we should be calling that with the main one. Okay, so let's go ahead and let's say, that's probably okay. Let's move on. A little more work to do before we run out of time here for class. Okay, so the whole idea then for this idea of finding an efficient frontier is to say, let's do this. We've got some range across which we can expect to get a return, anywhere between 2% and 8%. So what our find frontier procedure should do is it should say, well, let's start at 2%, and then let's add, we've got, what do we have, 10 here? Add 1/10 of the difference between the low and the high, and then make that my required return, and then optimize. Make that required return, and then optimize. And I think I have that procedure all written out. So all I should have to do is uncomment the find frontier button. And then when I run the whole thing, it should get the data, optimize, change the value we're looking for, and we'll do a graphic here. Let's take a look at it. So now what it's done is it said, all right, with a required return of 0.02, a low required return, these are the optimal weights to be able to get the minimum variance, and that's here, or the minimum standard deviation. As I change what my required return is, the way that I should allocate my stocks changes. Apparently, I should never buy Oracle. And then this then is just a graph of this set of data. So anywhere to the right of this graph is somewhere I could be. It would be more risk. To the right of this line is accepting more risk. To the left of this line is impossible. I can't get there. So what I can't do is get, this is my expected return over here. So at the expected return of 0.07, I can't get lower risk than whatever that is right there. This out here is not available to me. Anything to the right of this is, but if I'm to the right of this line, what does it mean?
More risk.
Yeah, for that particular expected return, I'm undertaking more risk than I need to be. Ultimately, I want to be somewhere right here along this line as I allocate this is kind of a standard efficiency frontier that you would expect to see in a problem like this. But it can be generated entirely automatically from what we're doing here. Question?
Sorry, when you find out why solver wasn't, do we know that the solver wasn't making the thing negative, or was it?
No, it sounds like the solver is actually, the solver is making it negative, but it's only making it a tiny bit negative. If we look at these negative numbers, oh, this one looks like it did it right. Come back
Well,
to
it's
figures.
because you changed it.
Oh,
Did you change the precision?
I did not change the precision. And plus, it's blowing away the solver each time. So it looks like that first time when it runs it, for some reason, it's not at that precision. But when we run that frontier, it runs this optimize button multiple times. What do I do? No, I don't. Oh, yeah, here it is. Yeah, you're right. So this one, thank you. So this one is times 10 to the negative 9th. So I've got a bunch of zeros out here. This is 0.00000 negative 0.000000000000057, really close to zero. And what one of our students suggests is that it's just a matter of the solvers saying, you know what, I'm within the realm of precision that you've asked for, I'm done.
Did you change any other constraints? Because before it was weighted differently.
So yeah, we changed this. So that's the whole thing about calculating that frontier, is that we plug in a different required return here and then solve. So the whole point why we want to say this is, and that part of running this model over and over again to be able to generate this chart, that's the whole reason why we want to be able to automate this. I mean, if it was just finding the one number we're looking for, we don't get a whole lot of bang out of automating. Automation, thank you. And so, yeah, that's why this last part of this example is here, so that you can see, set it up, run the model, change something, run the model, change something, run the model. That's the point. Question?
Yeah. So how does, when the frontier is being calculated, the efficiency frontier, if I understand it correctly, it's doing steps between the upper and the lower bound. Is that correct?
That's right.
Returns.
What it says is, it says, here's the range that I could possibly have. How many, let's see. I think it just automatically divides that into tenths. And so it runs this 11 times. Takes the bottom number, adds a tenth to it, adds a tenth to the difference, adds a tenth to the difference to the next one. And so we end up with 11 runs.
Okay, and is that something that are those steps of tenths something that we built into the code?
The question is, are those steps of tenths something that we built into the code? And by we, if you mean the royal we, then yes. It's something that I built into the code. It's right here, this procedure called find frontier.
Okay.
So in fact, it takes an increment of 10. If we change that to 20, then it would do 20, put into 20ths.
Make it more precise.
Yeah, and so all it does is it sets the required return equal to the minimum return plus 1/x of the difference between the minimum and the maximum return divided by whatever my increment is. So this will give me, the first time through, it'll take the minimum return plus 0 of that, 0/10 of the difference. The next time through, it'll take the minimum return plus 1/10 of the difference. The next time through, the minimum plus 2/10 of the difference. And so it'll give me an even set of numbers between the minimum and the maximum. And again, this code, there's nothing in this code here that's magical that we haven't talked about in class. Building the chart, everything is stuff that we've covered. So if you're really interested in this example, you should be able to look at it, go through it. Yep.
So in this example, you're getting CSV files from Yahoo Finance, right?
Correct.
So and how do you know if you can get CSV files from all the websites?
How would you find that out? The
Yeah.
question is, so where else could you get this stuff? And the answer is, I don't know. I found it at Yahoo and put looking. I don't know who else will freely give out historical data. My guess is probably someone else does. Because it's data that you could get at, and they want to get your eyes over there, so they'll get you.
And this way is faster than using a web query?
So this way is faster using the web query. The answer to that is faster than a web query. Not necessarily faster than a web query. And I'm not sure what the web query would do. Well, the web query is going to dump it onto a sheet. And so, yeah, I'm not even sure what would happen if we passed this off to a web query. It would be interesting to find out what it would do with this data that came back. I really don't know what it would do with it. But yeah, this is that object built in is one of the fastest, if not the fastest, way to interact with web pages. Very little overhead involved. So that's kind of nice. All right, folks, other questions here?
While the code was running, but if you found an error, you wouldn't want to suppress that. You'd want it to stop. Like if solver couldn't find a solution, is there a way you could?
Yeah. So here's the question. So what if, we've got things configured and we run it and solver doesn't find a solution? Is there a way for us to tell that by looking at the solver object? The answer is I don't know. There may very well be a way to kind of look at the solver object and say, did this thing solve? I've never tried to do that. That may very well be. All right, let me go ahead and stop the recording and we'll conclude the class.